Assalamu alaikum kids. So in this video we are going to discuss how to measure length, the instruments and the different techniques which can be used to measure lengths in various different ways. So let's talk about the various different instruments which can be used to measure various different types of lengths. Example, radius, height, thickness or depth. A lot of different instruments can be used. Example, meter rule, Vernier caliper, micrometer, measuring tape. These are all instruments which you need to know of in your O levels. But problem is that not all instruments can be used to measure all types of lengths. Example, a meter rule can be used to measure the length and width of a chart paper, but not its thickness. Thickness can only be measured by more accurate instruments. Example, Vernier caliper or a micrometer screw gauge. Another example would be that a meter rule can be used to measure the length of a pipe, but not its circumference. Why? Because meter rules can only measure straight lengths. They cannot measure curved lengths. Another important thing to know about an instrument is its accuracy, which is the smallest length that an instrument can measure, and it can be determined by the smallest division of an instrument. What is smallest division? Really simple. The smallest division is the distance between any two consecutive markings on an instrument. So the first instrument that we're going to be talking about is a meter rule. This picture right here shows you what a meter rule looks like when it's 100 centimeters long. A meter rule is not 30 centimeters long, it's 100 centimeters long. The smallest division, which is the smallest length a meter rule can measure, is 1 millimeter or 0.001 meters. The maximum length that 1 meter rule can measure is 100 centimeters or 1 meter. Now, why do I say that 1 meter rule? Why? Because you can always measure more than 100 centimeters by placing meter rules side by side. But that's problematic. It's not recommended to use a meter rule to measure lengths more than 100 centimeters. Why? Very simple. When you have multiple meter rules side by side, there's a dead space at one end of the meter rule. And if we don't account for the dead space in between meter rules, it can become very inaccurate. So if we are not supposed to use meter rule, then what can we use? We can use measuring tapes, because measuring tapes can be hundreds of meters long. So essentially, measuring tapes can be very efficiently used to measure lengths of more than 100 centimeters. Another problem with meter rules is that they can only measure straight lengths. Meter rules cannot measure curved lengths, as we mentioned in the previous slide. So let's talk about advantages of a meter rule. The advantage of a meter rule is that number one, it's very cheap to manufacture and it's very easy to manufacture. You just have a piece of wood and you have laser engraved markings. But with that, because it's cheap and easy to produce, there are some disadvantages as well. Very first one is because, again, these aren't sturdy materials. These aren't very strong materials, plastic and wood. The readings on them can wear out and the meter rule itself can get damaged. And hence the problem is that these meter rules, even though they are cheap, they generally have to be replaced quite often. Readings can vary slightly between manufacturers, so that's a phenomena. Why? Because again, each manufacturer may be using different machines, maybe have some different calibrations. Hence, meter rules from different machines may give you slightly varying measurements for the same object. Another problem with meter rule is that, we've discussed this before, that they can only measure they can only measure straight lengths and not curved lengths. An example of that would be that, let's say, for example, if we have these three pieces of wires. Now, of course, the first one, the meter rule should very easily be able to measure. But the second and third one, the meter rule will not give accurate measurements. So again, the first one is straight, the meter rule can measure it. The second is curved, a meter rule cannot measure it. And the third one is just damaged. So we can say that it's damaged. Hence, again, the true length will never be recovered. The second instrument that we're going to be talking about is the Vernier caliper. Now this right here is a picture of the Vernier caliper, and the different parts of a Vernier caliper are, number one, its upper jaws, its lower jaws, and the depth gauge. The maximum length that a Vernier caliper pen can measure depends on the kind of Vernier caliper you have. They can vary from 10 to 20 centimeters. They are generally very accurate in measuring length and can measure up to 0.1 millimeters. Now mind you that in the previous slide we saw that your meter rules can measure only up to 1 millimeter, not below that. Hence, a vernier caliper is at least 10 times more accurate. It can be used to measure the inner diameter. Now, vernier caliper is the only instrument you can use to measure the inner diameter of a pipe or a test tube. It can also be used to measure the depth. Alright, so the depth gauge, it extends as well, and the extension of the depth gauge tells you what the depth of a certain object is. Of course, it's limited in use for very small depths. The problem with vernier caliper is that it's prone to, after constant use, it's prone to developing zero error, but that can be easily mitigated by using different techniques. Alright, so again, that's not in our course right now, so we don't care about that as well. So meter rule, then vernier caliper in increasing accuracy, and the most accurate instrument in measuring length is the micrometer or the screw gauge. Now this right here is an example of a micrometer screw gauge. We are going to discuss about how to do lengths or how to measure lengths with a micrometer if need be in a separate video. Right now what you need to know is that it's the most accurate instrument to measure length that's in our course. It can measure only up to 5 centimeters. So it does not, you cannot measure very large lengths with a micrometer. It can measure up to 0.01 millimeters or 10 micrometers, and hence we call it a micrometer. Why do we call it? Because it can measure in micrometers. So the last instrument that we're going to be talking about is a measuring tape. This right here is an example of a measuring tape, or a type of measuring tape you'll usually see tailors have. And this right here is another type of a measuring tape again, which you'll usually see carpenters use. The smallest division on a measuring tape is generally like a meter rule. It's 1 millimeter or 0.001 meters. The only advantage that a measuring tape has over a meter rule is that it's flexible. The maximum length it can measure, again, that's another advantage over a meter rule, is that it can measure very, very, very large lengths. The advantages of a measuring tape in general are, number one, again, like a meter rule, it's cheap to produce and it's easy to manufacture. It's flexible, hence, number one, it's portable, and it can also measure curved lengths because it's flexible. The disadvantages of a measuring tape being that, again, like a meter rule, the readings can wear out over time, so it's got to be replaced time and again. And because it's flexible, you have to have the measuring tape stretched, or a particular term that we use for it, we need to have the tape taut to make sure that our measurement are accurate, because if the measuring tape is left relaxed, it will bulge out from some point and it's going to give you an inaccurate reading. So this right here is all about the different instruments which we can use to measure lengths.